Welcome back to 11 Things About Data. I'm Alistair Kroll, chair of Forward 50, and I've put together these 11 lessons to help you think about and navigate a data-driven world in which we all live. Now I want to talk about the move from preciousness to abundance. Once upon a time, computers were really precious. They were incredibly expensive, incredibly rare. The humans were abundant, the computers were scarce. If you were in university, you carried stacks of carefully punched cards into the computer room in the wee hours to run your computing job. And that's one of the reasons why we have thought about data wrongly. Now, data itself is not new. Data has been around for a while. Here's a picture of Mary and Joseph registering for the census 2,000 years ago. And we've used data to direct business and organizations for decades. In fact, the PRISM model, the potential rating index for zip markets, was developed in the 80s as a way to target specific people by zip codes. But that was still precious, and it was still very, very coarse. What's new about data today is that the equation or the value of that data has changed. Data scientists and big data proponents talk about the 3 V's of data. Data can be big, that's volume. Data can be transmitted very quickly, that's velocity. And data can be varied. It can have a lot of different types of things, different objects, large and small records. Those 3 V's were first outlined in 2001 as the idea of big data. The problem is you can pick any 2 of them. It's easy to get something that's big and varied as long as you don't need to go through it too quickly. A library, for example, can have thousands of books, and they're all different. But if you start shuffling around quickly, the library will break. A coin sorting machine can process a tremendous volume of coins very fast, but those coins can only be 5 or 6 different types. So you get volume and velocity, but not variety. And a spreadsheet can give you some velocity, fairly quick analysis, and variety, but it doesn't have a lot of rows. And so you always had to choose which 2 you were trying to solve for. There was always a trade-off. What's happening with big data is that the constant, big times fast times varied, the constant has dropped precipitously. And when things get vanishingly cheap, brand new ideas merge. So we now have the ability to search the sum of all human knowledge in under a second for free. So cheaply, we don't know how to bill for it. The best we can do is run some ads for you. This is part of what's called Jevons paradox. Efficiency means lower costs. Lower costs mean new uses. New uses means more demand, and more demand means more consumption. We are in this constant cycle of creating new uses and consuming more data, which makes us more efficient, and that is dramatically accelerating the way in which we work with data and how much we rely on it. Now, once upon a time, when computers were scarce, we had to organize things in hierarchies. That meant structures and directories with someone curating them. If you think back to the early days of Yahoo, Yahoo had a directory. Yes, you could search it, but someone had decided that news and media was different from business and economy, and that Beanie Babies belonged in a certain part of the hierarchy. This was hierarchical, and it's very similar to what we think of when we think about org charts or how accounting documents are put together. Somebody builds the structure first, and then we pour information into it. That structure or that schema is a hierarchy, top-down, curated, people in charge get to choose what goes where. Around the same time as this Yahoo website, there was a young upstart called Google. And Google said, you know what, just type something in. We'll figure out what's right and how it's related to things. They came up with an algorithm based on relevance that made it easy to access information without a lot of curation. So if you take one big change away from the rise of cheap, abundant computing, it is this. We have changed from an old model where we ask the question and then collect the data to a new model where we collect the data and then ask the questions. If I'm running an organization and I want to know how many widgets I sold by size, by color, and by city, first of all, I'm going to define the structure of that information. If this is a spreadsheet, I'm going to give each of the columns the names I want. Then I'm going to send people out to collect that data, and I'm going to put it in some kind of database or data warehouse or some other storage device. You can just think of it as a spreadsheet. And then I'm going to run a report. And now I go, maybe it's the weather as a result of my report, but maybe it isn't. And now I got to start all over again. The new way in an era of abundant data is to collect all the things and then ask questions. So I collect a ton of information, every single sale of every single product at every single store in every part of the country, and I collect other information like the weather or the political affiliation of the purchaser or whatever. So that stuff is all poured into what's called a data lake. It's a big puddle full of data. And then I go, hey, give me a report on widgets by size, color, and city. That's the same question I was going to ask in the first place. But notice that I've collected the data already. And the system goes, all right, I'll give you that report. It comes up with a structure. And I look at it and I go, maybe it's the weather. So then I say, give me a report of widgets sold by weather. And I go look at it and it isn't the answer, but it causes me to find another question. And I go, maybe it's political affiliation. Oh, it's widgets by political party. And I find out that different political parties buy different widgets. So the cycle of data has fundamentally changed. The old model was ask a question, define what I need to collect to answer that question, go get the data, answer the question, and then probably come up with a new question and start all over again. But the modern model is collect first and ask questions later. This dramatically speeds up the rate at which we can explore data. But I should also point out, this is a two-edged sword. Most of the modern discussions you see around privacy stem from the simple fact that once upon a time we had suspects and collected data on them by dumpster diving and investigating them with a warrant. Today, we have data and we look for suspects in it. Most of the conversations you see around privacy and around crime and recidivism and computer bias stem from this one big fact. There's some other consequences of abundant search. Take hashtags, for example. The simple hashtag doesn't seem that powerful, but it is actually a much bigger deal than you think. The Medicis, the founders of modern accounting, came up with what's called the general ledger, a well-known structure in which we record all of the information we have. Now that structure exists in a very formal way, and accountants go to school for years to learn about it. But if I have a cup of coffee, where do I file that cup of coffee? Is this Alistair or cup or coffee? Do I file this under people named Alistair? Do I file it under beverages named coffee? Do I file it under containers named cup? That's not really how humans think. If I were to put this in a filing cabinet somewhere, which filing cabinet do I put it in? And how do I make sure that the other filing cabinets also know that it's there? Well, when we didn't have search, we just had to come up with a way of filing it and say cups always go under containers. Go look in the containers section for your cup. But I couldn't find out who the cup belonged to. Hashtags change all that. Hashtags are a consequence of abundant, cheap search. We now have the ability to slap any number of labels onto something and then find that information. So search isn't just about finding things quickly. It's about abandoning the centuries-old regimented structures and schemas, and instead collecting things and then asking questions of it in a careful way. And all of the different relationships between the data tell us more. They give us more context. I can find out what this is. I could even go in and type in decaf and add that as a label. And each of these labels might be true or might be false. So I now need to think about where did the data come from? How much do I trust that person? And so on. We're going to get into what to think about data in the next of these sessions when we talk about what makes a good metric.